Yes, welcome back. Today we are going to be learning particulate nature of matter and separating techniques. Particulate nature of what? Matter and separating techniques. Particulate nature of matter and separating techniques. That's what we're going to learn. We say that chemistry is the study of what? Nature, composition and properties of what? Matter. So now, today we want to know what this matter is all about. You understand? What is this matter? And matter is defined as any substance that has mass and occupies what? Space. Any substance that has mass and occupies space is matter. Matter is any substance that has mass and occupies what? Space. Example is air. Is that clear? The air we breathe has mass and it occupies what? Space. So the air is matter. Another example is water. The water you fetch with a bowl, it can occupy the space inside that bowl, is it not? Then when you put it on a weighing balance, you will see that it has what? Mass. So anything that occupies space and has mass is what? Matter. Is that clear? So water is a what? Matter. Another example of matter is soil or sand. The sand that you pick, it has mass, isn't it? It's heavy when you carry it, and it occupies space. It's occupying the space where it is on the ground. Or when you put it in your hand, it's occupying the space on your hand, and it has mass. So sand is also an example of what? Matter. Is that clear? Another example is animals, plants. Me like this, I have mass, and I'm occupying this space. Can somebody come and stand this very place I'm standing now? Because I've already occupied the space, so I'm matter. Another example of matter is plants. You understand? So you see that virtually most things that are in existence are examples of what? Matter. They are examples of what? Matter. So they must have mass and occupy what? Space. So matter is any what? Substance, is it? Or anything, any substance that has mass and occupies space. E.g., example is what? Air, water, land, plant, plants, animals, etc. So that is what matter is. Now, when we talk about mass, you understand, there is another quantity known as weight. Both of them are similar, isn't it? So Jam might want to know whether you know the difference between mass and what? Weight. The difference between what? Mass and what? Weight. So we are going to look at the two of them. Mass and weight. What are the differences between mass and what? Weight. What are the differences between mass and weight? As a physics or chemistry student, you are supposed to know these differences. Mass is the total quantity of particle in a substance. Mass is the total what? Quantity of particle in a substance. Matter is the total quantity, mass is the total quantity of particle. You understand? Yes. In a substance. Or you can also say it's the total quantity of what? Matter. Matter in a substance. Whereas weight is the what? Force acting on a substance due to gravitational pull. Weight is the what? Force acting on a substance due to gravitational pull on it. You understand?
Yes.
So matter is the total quantity of Mass is the total quantity of matter or substance in a very particular substance. Whereas weight is the gravitational pull the earth exerts on that very substance. That's why the quantity of matter, let's say mass, my mass on planet Earth is the same thing as my mass when I go to moon or anywhere. Mass is constant. You understand?
Yes.
But weight is not the same. My weight here will be different from my weight in the moon, because the gravitational pull here on Earth is bigger than that in the moon. Is that clear? So there is this disparity in weight, but mass is constant. Is that clear?
Yes, sir.
Now, mass is constant, it does not vary. That's number 2 difference. Mass is constant. And when you say that something is constant, it means that it does not what? Vary. It does not change. Your mass here is your mass. Your mass at the equator is the same as your mass at the North Pole. Is that clear?
Yeah.
Whereas weight varies as force of gravity changes. Weight does what? Varies as the force of gravity changes. So anywhere that has larger force of gravity, you will have bigger bigger weight. But mass does not change. Mass is a scalar quantity. It has both magnitude and what? Direction. Mass is a scalar quantity. So mass is a scalar quantity. It has magnitude but no direction. Magnitude but no direction. Whereas weight is a what?
Vector quantity.
Weight is a vector quantity. And what's the meaning of being a vector quantity? It has both what? Both what? Magnitude and what? Direction. So any quantity that has both magnitude and direction is known as what? Vector quantity. Whereas the one that has magnitude but no direction is what? Scalar quantity. So mass is a scalar quantity. Weight is a vector quantity. Because weight is always drawing you towards the center of the earth, is it not?
Yes.
So that's the direction. Now another difference is that the SI unit for mass is mole. The SI unit for mass is what? Mole. That's the SI unit for mass. Whereas the SI unit for weight is what? Newton. The SI unit for weight is Newton. The SI unit for mass is what? Mole. So those are the differences between what? Mass and what? Weight. Those are the differences between what?
Mass
Mass
and
and what? Weight.